Welcome everyone. We would like to ask you to take your seat. All the partners can sit at the seats that have partner seats assigned. They are at the front with the bags. Thank you.
Good afternoon, everyone. I'm so glad to see all of you out here today on this very special day for us. Today, we are here with a lot of different people from a lot of different backgrounds, but we share a common connection. That is, you are all somehow part of our crazy idea to start building a hydrogen-powered boat to sail the North Sea. My name is Daan Postumus. Normally, I would be Chief Embedded Systems at Hydromotion, which is just a fancy name for electrical engineer. But today, I'll be your host. Some of you here might be partners who know us from our functions within the team, who talk to us about what specific bolt to use or what chemical is nice to keep our electronics safe. Others here, and I think they're all in the back, are our parents, our friends, our families that hopefully still recognize us today, since we have been working so hard on this project that, well, we might not have been home as often as we used to be. Some of you might even have made the connection that it had to do something with the thing that is behind the curtain here. And that thing is, of course, our boat. And today, we are here together to, well, as you may have guessed from the name of the event, reveal our boat for the very first time. And I can say that we're all here very proud, and we cannot wait to do it, but we cannot do it just yet. That is because we couldn't help ourselves to also take some time to talk about why we are actually doing this, about the things that inspire us and the things that are related to our project that we think are really interesting to tell. So today we will start with a lecture from none other than Ad van Wijk. Ad van Wijk is Future Energy Systems Professor at TU Delft, and he will talk about hydrogen. Afterwards, we will have a panel discussion about sea travel, since this is the first time we are actually going to travel overseas as a foundation. Then finally, Carolina will tell something about the production and assembly process. And, of course, we will be revealing our boat for the very first time. All right, let's start at the beginning. We started in August last year as a group of 23 very overconfident students with either a passion for sustainability, building boats, or building aircraft in a weird way. Looking at you, all the aerospace engineers. But only Doris, our maritime engineering student, actually knew how to build a boat. But soon enough, we discovered that what they teach you in university isn't always as practical as we think it is. So we started by trying just a lot of things, and with the help of alumni and partners, we actually started designing, building, and testing a hydrogen-powered boat. During these last 9 months, we've gone through several phases. We started by determining our challenge for the year. We set our boundaries, and we started making rough sketches. Some of these sketches were more realistic than others, but that's okay, because we've learned a lot from them. After setting a general design, we started on working out all individual components, which came together at our design presentation in December last year, where we, well, as you may have guessed, revealed our design for the first time. And since then, we've been working hard on actually producing and assembling our boat. And today is then finally the day that we will show the boat for the very first time. During these last 9 months, we not only worked on creating a hydrogen-powered boat. No, we had many fun activities together, had many dinners together, and we really got to know each other. We went from just being students to becoming a real group of friends working on an ambitious project. All right, let's start at the why. We want to start today off with a presentation about hydrogen. This is because hydrogen plays not only a key role in our project, but also in making the world more sustainable. I could give you a lecture on this, but I think I could never do it as good as Ad van Wijk would. He's, of course, a future energy systems professor at TU Delft, and has spent much of his time on actually researching the hydrogen economy. So, please give a warm welcome to Ad van Wijk.
Thank you very much. Dear all, it's really good to see you here. Here at this event from Hydromotion, a crazy team that want to sail across the oceans. The other one? As I said, a crazy team that want to sail across the oceans on a boat powered by hydrogen. Yes, indeed, hydrogen, a mysterious element. The universe exists on hydrogen. 75% of the mass in the universe is hydrogen. But on Earth, we don't have hydrogen in a free form. But it is among us. It's a hidden element. It's hidden in water, for example, or in our fossil fuels, the so-called hydrocarbons. And suddenly, we see that hydrogen has to play a key role in that energy transition. But why? Why is hydrogen so important as a key element in that energy transition? That's the question that I want to discuss with you. But before I do that, let's go a little bit back in history. And let's see what we have achieved in the past decade, you could say, in our energy transition. And especially in developing solar and wind producing electricity. Today, at the good places, we can produce electricity from solar for about 1 to 2 cents per kilowatt hour. And for wind, that is 2 to 3 cents per kilowatt hour. But what are these good locations? You see here a map, the solar irradiation map, and the wind speed map. And the dark red areas are the areas where we have the highest wind speeds or the highest irradiation. And as you can see, that's and the cheapest production we have at these places where we have, of course, the highest irradiation or wind speed, but also where we have a lot of space available. And as you can see, you see that especially in the desert areas, we have not only the highest irradiation, as you know, but also the highest wind speeds. For example, across the Red Sea, the wind speeds are on land higher than at our North Sea. And that's also where we have a lot of space available, of course. And therefore, we can produce in these areas very cheaply our renewable energy. And then the first question people ask, yes, but do we have enough space on Earth to produce all our energy with solar and wind or with the renewables? Piece of cake. If you cover 11% of Australia with solar panels, we have produced all the energy of the world. That is that figure over there, 168,000 billion kilowatt hours, terawatt hours. That's not only electricity, that's only 20%. But it is also for the industry, for mobility, for heating and cooling buildings. All the energy we need, that's that figure. Only 11% of Australia. We can do it also with wind. Then we place every kilometer a large floating wind turbine at the Pacific Ocean, and then we need an area of 1.5% of the Pacific Ocean. All that energy is produced in that area. We can go a little closer to Europe, the Sahara Desert, for example. There we need only 9% of the Sahara Desert to produce all that energy. The third one. I guess I get more. Okay. The Sahara Desert, that is bigger than Australia. So we only need 9% of the Sahara Desert to produce all the energy for the world. But now it comes. The Sahara Desert is 2 times as big as all European Union countries together. And in the Sahara Desert, we have only 1 person per square kilometer or less. And in the European Union, it is 120 persons per square kilometer. And of course, we can produce a lot of our renewable energy in Europe, and we have to do that. But in the end, we need to import a lot of the renewable energy from elsewhere where we can produce it much cheaper than in our countries. Unfortunately, maybe, but that's the reality. How do we do that? Because then the next challenge is not making it cheap, but the next challenge is how could we bring that renewable energy at the right time to the demand of energy, at the right place, you could say. So the next challenge we are facing today is bringing the energy that we can produce cheaply to where we can use it. And that's not only for this side, but also when we want to produce it from the North Sea and bring it to the shore. And there hydrogen comes in. Hydrogen. How can you produce hydrogen? You can produce hydrogen in many ways, but what we talk about here is we want to produce hydrogen from water, H2O, and we put in electricity, and then the hydrogen molecule is split into hydrogen and oxygen. The process is called electrolysis, and the technology is an electrolyzer. We can do also the reverse process, and that is that we take oxygen from the atmosphere, it gives a reaction with hydrogen, and then we produce electricity, and then we get water as a waste product. In fact, this is the fuel cell that we will see that is powering the boat here. And that this process is what you see here in this boat. Now you can ask yourself the question, or you can ask yourself the question, if we look to this process, really hydrogen is what you call a circular energy carrier. Because on the first hand, you produce it from water. You need 9 liters of water to produce 1 kilo of hydrogen. The oxygen is released into the air, for example, and then you use it in your fuel cell. You use the same amount of oxygen that you have produced first, and you produce also as a waste product the same amount of water. So it is not using oxygen, it is not using water in the end, it is a circular energy carrier. But now, coming back on why do you want to do that conversion from electricity to hydrogen? Why are you not transporting the electricity itself to where you want to use it? And that is because it is much cheaper when you convert to hydrogen to transport the hydrogen and to store the hydrogen than when you do that with electricity. And that has everything to do with the energy density per volume and per weight. If you look how our system works, the most expensive way to transport energy is, for example, by hot water in a pipeline, our district heating systems. 10 times less expensive is electricity transport. But then 5 to 10 times less expensive is gas transport, and that is, for example, also hydrogen. And the least expensive, that is transporting oil, a liquid, through a pipeline. And therefore the energy system looks like this. We transport by ship over the oceans a liquid, because that has the highest energy density. We can transport by pipelines over distances of about 5,000 kilometers gases and oil, liquids too. But electricity is only a regional component that you can transport feasibly about 1,000 kilometers on distance, and locally you transport your hot water system. And therefore, it doesn't make sense to transport hot water over distances of 1,000 kilometers, because then it is way too expensive. And when you want to design a system that is feasible and that is also not expensive, then you see that even when you do these conversions, in the end, you have a cheaper system. And that is the main role of hydrogen in the system of the future. But yeah, 150 years ago, there was Jules Verne. He has written the book, A Mysterious Island. And already at that time, he wrote, "Yes, my friends, I believe that water will one day be employed as fuel, that hydrogen and oxygen, which constitute it, used singly or together, will furnish an inexhaustible source of heat and light of an intensity of which coal is not capable. 150 years ago. He started his book with 5 prisoners during the Civil War in America, and they escape from the prison by a balloon filled with hydrogen, and they produce the hydrogen by a reaction of iron with an acid. That is what he described already. It was already a fuel in that day, or he thought it could be a fuel. Why has it taken 150 years before we now entering into that fuel? And I've given the answer already a little bit. Of course, we first have to develop cheap renewables, solar and wind. We are now at that stage. And now the next challenge comes, and that is how can we transport and store that? But it is even more difficult. If you look to this challenge of creating a hydrogen economy, or a hydrogen system, you could say, then we see that we do not only have to develop the technology to produce hydrogen, and electrolysis is not the only technology. We can produce without CO2. It's also from biogas or even from natural gas. And we have also new technology that we can directly use the sunlight to produce and to split a water molecule in hydrogen and oxygen, the photolysis cell. But we have to develop at the same time also the infrastructure, because that's not there. We can reuse our gas infrastructure, but we have to develop also the storage. We can reuse the gas storage. And at that end, we have to develop also the technologies like the fuel cell for all these applications where we can use hydrogen. And that is an immense challenge. It is also a mysterious challenge, so to say, because in the end, you have to develop all these things together at the same time, in the same pace, you could say. And that makes it a very, very, very difficult challenge. And that asks for directions, of course, directions from governments. But if we have to wait on our governments, and therefore, we have, luckily, the dream teams. We have companies, we have people, but especially these dream teams, they take up part of this challenge. On land, we have 2 dream teams creating a race car on hydrogen. Also, the Eco-Runner, which is a team that wants to drive on 1 kilo of hydrogen as many kilometers as you can. On air, a team that is developing a plane on liquid hydrogen, flying over there. And at sea, hey, where is the boat? Oh, that's what we want to reveal. Thank you very much.
Thank you very much, Ad. I think you've shown us all why we need hydrogen, and I think it's time for us now to take on the challenge of actually showing why hydrogen is useful and how it is being used in the maritime industry. So thanks again. So in a few moments we will be having a panel discussion on sea travel. But before we go into that, I think it's nice to start now with a small introduction about what our challenge will be, how we will take on our sea travel. So let's start at the logistics. We will start in Rotterdam with our own boat, with a support vessel, and with a ground team, which will follow us along the route. We will sail, well, first from Rotterdam, along the Dutch coast, along the Belgian coast, and then just before reaching France, we will cross to England. Once we're in England, we'll sail to Ramsgate. And in Ramsgate, we will stop and stay the night. And then on the following day, we will sail up the Thames to London, and we will reach our goal of sailing to England. Along the route, we have sought out contact with many harbors for, in case of an emergency or a quick repair, that we can stop there. Then we move on to the second part, which is safety. Safety plays a huge aspect in our travel, because since we're all not really experienced sailors, especially not on the North Sea, we still want to be able to sail safely. Therefore, we have taken multiple precautions. The first one is that we've created a more safe boat than ever before, with a bigger hull, which we'll show just in a minute, a hydrogen system that is safer than ever before, and electronics that are tested even more. We think we can sail safely. But if something happens, our pilots have gone through extensive training on sailing the North Sea, but also on what to do in case of an emergency. Then finally, we have some legal stuff. Of course, there's legal stuff. But there's not a lot of legal stuff yet for us, because since we're working with such an innovative new fuel, there's not a lot of regulation for that. For instance, when we called the London Port Authority at the start of our year to ask if we could sail the Thames with a hydrogen-powered boat, they simply replied, "We don't know." And then we have some other legal duties we have to fulfill. And for that, we have partners like the KNRM. And speaking of the KNRM, let's introduce our first panel guest. Our first panel guest is the operations manager of the KNRM. His name is John Gill. He has worked for more than 20 years at KNRM, so he will probably know what sailing on the North Sea is like. Then we have Marco Rebijn. He is a rower, but not your ordinary rower. He is part of Team Out of the Blue. And Team Out of the Blue have sailed across the Atlantic Ocean in their rowboat with just 4 rowers. So if anyone knew how to travel the ocean, I think Marco would be the guy. And then finally we have Alice Huistra. Alice is of course part of our team. She's the operations manager of our team, and she will give you more insight into our preparations, our direction during the crossing. So this is the moment to ask you to come forward onto stage, and let's have a panel discussion. Let's wait till we have a seat. This is all the next team here doing the nice hard work. So next year we'll be here looking proud at them, having their own boat. All right. Well, thanks of course for coming. I think it's nice to start with you actually telling a little bit about yourself, since I did the introduction, but yeah, who could do it better than you yourself? And maybe you could tell a little bit your experience with sea travel. So, John?
Yes, thank you for inviting me. My name is John Geel, Head of Operations at the KNRM, the Dutch Sea Rescue Institute. We have 45 lifeboat stations around the coast of the Netherlands and the inshore waters. And we are a non-profit organization doing search and rescue at the North Sea and the inner waters. 1,500 volunteers each day. They're ready for a SAR mission at the sea or at the water, and within 10 minutes we will react after an alarm. My own experience is I've been in early days when I was young. I've been a merchant shipping engineer. I've sailed for 10 years on tugboats, on heavy transport vessels and that kind of things. And since 2001 I joined the KNRM. First of all as a technical inspector, later in the operations, and now I'm responsible for both operations and the technical department.
That sounds like enough experience to tell us more about how to travel.
Yeah,
on the North Sea.
and also I like to sail on my own sailing boat.
Sure. Then Alice, what's your experience on traveling the sea?
I think compared to everyone else on stage, I have the least experience of traveling the sea. I dabbled a little bit in sailing in my youth, but was never very enthusiastic. But I do really like boats and water. So I'm here representing the team and, representing what we've been working on and all the preparations for that.
Yeah,
Yep.
now Marco.
Yeah, thanks for the invite as well. Marco, as you said, team out of the blue. We're three students and one graduate who were based in Delft, and my roommate saw this race that exists apparently, where you have a fleet that races across the ocean unsupported and all by themselves. And three of us didn't have any prior ocean experience, and three of us never had any rowing experience. So the four of us came together about 2.5 years ago, and just 3 months ago we came back from Antigua and rowed from the Canary Islands to Antigua, which is about 5,000 kilometers, and took about 36 days.
That's quite long.
Yep.
So let's start with some expectations, and I want to start with you. What is something you didn't expect to see while rowing out on the sea, on the big ocean?
Yeah, I mean, there was a lot of uncertainty. That was a big word before we departed on the ocean. It was like a 2 weeks we were in the Canary Islands, preparing the boat and looking at the weather, checking the equipment and everything. And there was just a lot of uncertainty. And when we actually got on the water, I didn't expect to see so much wildlife. So I expected it, but I didn't think we would see sperm whales. We had 20 sperm whales that came up to the boat. And especially annoying were the flying fish, which I don't know if you've had that, or you might have that. But essentially we got hit in the face, in the back, in the shoulder every day by flying fish. So definitely didn't expect that.
That's quite unexpected, yeah. And John, if you, what are like common pitfalls that you see that people don't expect when traveling the North Sea, for instance?
I think when you're looking especially to the recreational boaters, so not the merchant shipping, but the recreational boaters, the underestimation of the North Sea. The North Sea is completely different, of course, than the inner waters like the IJsselmeer or Waddenzee. There's a lot of current, there's tide, there's other shipping, sea state, waves, and people are sometimes not well prepared when they're going to the North Sea. So underestimation is the biggest risk for them.
Okay. And Alice, have we prepared?
I think we are definitely in a process of preparing. I think the first step is knowing that you are unprepared and then saying what we can do to stop that as much as possible. So talking to people like Marco and John definitely helps with that.
Okay. And John, what are preparations you would advise us to do? What are preparations that you take, that your colleagues take when going to the North Sea?
Yeah, when you're looking to our crew members, all volunteers sometimes have some experience in the water or on the water and sometimes not. But training and education is for us the most important thing, of course, to be prepared for going to sea. But also your materials, our lifeboats should be reliable, so maintenance is very important. Everything should be checked and over-checked again, so that, as I said, should be ready within 10 minutes. So as the alarm set off, you have no time for preparation anymore. So every moment of the day, you should be operational ready. And we're doing that by exercising, training, education, that kind of things.
And Marco, are your preparations similar? I think not. Yeah, I think you prepared in a completely different way for your travels.
Indeed, and there's some overlap there. For us, we didn't have much experience, and also because this was an organized race, there were certain requirements, safety requirements we had to meet, which included going to the UK. We could have probably also trained with you, by doing safety courses, navigation courses, seamanship courses, just so that everybody's at least on a minimum level. And then once we had like the theoretical knowledge sorted, we also spent 160 hours on the North Sea. We were training out of IJmuiden, training with the equipment, what it's like to go to the bathroom, what it's like to do man overboard drills, also the communication with other ships, how to read buoys and all this kind of stuff. And on top of that as well, for us, because we were spending such a long time at sea, we also had to look a lot into our kind of team dynamics, communication, and how are we going to act in crisis situations and things like this. And we did a lot of that work as well mentally.
I can imagine, especially when you're spending over 30 days with just 4 people on a boat.
Yeah.
That might be a good thing to take care of.
Yes.
Then Alice, on the North Sea there are several like weather conditions. How are we taking that into account when traveling overseas? What are our preparations for that?
So in the first 2 weeks of July, we have outlined a weather window in which we have calculated the chance of our boat being able to cross. That's the design preparations that we took at the beginning of the year as well. So the 2 weeks that we have decided on, statistically, there should be a 98% chance that we have a day where we should be able to cross. And of course, we have outside people outside of our team who will help us determine when it is indeed safe, so there's no inherent bias or as little as possible. And we have certain limitations. When the waves are over a certain height, we will not make the crossing.
Yeah. That sounds like a good plan, of course. John, you and your colleagues cannot wait for 2 weeks when going into a rescue. So how do you deal with intense weather situations?
Yes, an interesting question, of course, because when heavy storms are expected, we are always called by the media on, are you prepared? And we always are prepared. And when there is a forecast for heavy weather, for storm, we take the opportunity to exercise on that moment and to be prepared when it's a real situation. And with exercising in very bad weather, we can find our limits, because you have to know what your limits are when you are in a real situation, so you can rescue the people who needed your help. And you have to know when you have to stop or to reduce your speed. So we are ready all the time, and we try to exercise as most as possible when the conditions are there.
Okay. So even when it's bad weather, you're still going out training?
Yes, when it's bad weather, we try to find the bad weather to exercise.
Ah, nice. And Marco, did you encounter any bad weather during your trip? I can imagine within 40 days there's at least one day of bad weather on the Atlantic.
Yep, we did. The first week we had 35 knot winds, gusting to 35 knots. We perceived the waves to be like 8 meters high. They were probably a bit smaller, but we did encounter some pretty intense wind. And for a boat that moves as slow as us, so probably not an issue for you, but we had issues with maneuverability and spinning out with our autopilot. So we were always at risk of capsizing, and that's why we're always attached with lifelines. Pretty much those are the things that kept us safe and alive. And we had different redundancies in place, but the weather was a big factor, and as well as the heat for us as well.
The heat as well.
The heat and dehydration and these kind of things.
Yeah. And if you're looking at a more personal basis, what are qualities a person that would sail the sea really needs to have? I know this might be a hard question.
I think there's not one quality. I think everybody with enough training and a good team can make it work, but definitely communication is key. Having the right expectation, like having similar expectations and goals, and having a plan A, plan B, plan C, so that when you are in a tough situation, you don't have to think about what are we going to do next, but everybody already knows what their task is, and also being open-minded and not taking things personally. And that was a big case for us because we were essentially trapped
Yeah,
on
yeah.
a small boat
Yeah.
for us. So, yeah, I don't know. Similar
And
for
John,
you.
do you agree?
Yes, there is a lot of things Marco said already, but in addition, I think what's a very important quality is situational awareness. That you at any moment you are sailing at the North Sea or the ocean, you are aware of your environment, like the weather, the tide, but also the shipping around you, because and rowing is very slow, but our lifeboats are doing 30 knots, and then ships are closing by very quickly. So you have to be aware of the situation every time, and we train our crew also in crew resource management or bridge resource management, how you call it, to work as a team together. You cannot do it by your alone, so you have to collaborate together to sail the boat safely to the destination.
Yeah, that sounds logical. Indeed,
It
I
is
hope
it
we
is
can
also.
we can get that in our team as well. I'm quite sure of that. Let's end today with a look into the future. And John, I'm gonna ask you first. Do you see hydrogen as something that has potential for the KNRM in the future?
A very interesting question, and one of the colleagues of Ad, Klaas Visser, is asking me every day, almost, because sustainability is very important for us also, and we are replacing our fleet the next 10, 15 years, but in this moment, hydrogen is not suitable for us in our environment, fast sailing ships, heavy weather, and that kind of things, because it has to be reliable, trustworthy, and also the logistics should be in place. So for now, as a temporary, you can say, we are using common diesel fuel, and we're switching over to the HVO 100 fuel, which is a reduction of 90-95% of the carbon footprint. Our goal is in 2035 to have a 95% reduction of our carbon footprint. So that is the first step. But with the development of our new lifeboats, we've taken into account that we have to switch over maybe sometime to another fuel.
So in the next few years, we can all start working at KNRM to develop a new hydrogen-powered boat you can actually use.
Yes, maybe.
And Marco, maybe a little bit different because, well, if you're rowing, hydrogen isn't something that you can take. But with Team Out of the Blue, of course, you were also sailing for ocean health, for ocean wildlife health. Say if you were to cross the North Sea or the ocean again in 30 years, what would you like to see has changed?
Yeah, indeed. Like
In the industry or in general on the ocean?
Yeah, I think there's and definitely like with our message, we all kind of had that one thing in common, that we were guests on the ocean, so we want to see it also in 30 years to be healthy and thriving, and so that people have the chance to see the wildlife as well. For example, for us, the main source of energy were solar panels, and we use that to make water and to desalinate to water. And I think in 30 years, hopefully, hydrogen is also maybe a kind of a good source for desalination when we have water scarcity, which might be a thing. So it's not really related to rowing, but hopefully it can benefit in different areas.
I hope so as well, yeah. And Alice, what do we wish to reach with crossing the North Sea? What is the impact we hope to have?
I think what John said is a really good example of what we are hoping to achieve. We are hoping to prove that it is logistically, safely, and productively a possibility for ships to cross using hydrogen in the future. Maybe it'll be a patchwork of different alternative fuels, but we do believe that maritime industry and sea travel can get to the point where it can become zero emission.
And now our final closing question, which is more of a funny question. Say you were to sail a boat, a hydrogen-powered boat, across the North Sea to England. What would you never forget on a trip like this? Let's start maybe with John.
What I should never forget? I think the finish.
And Alice?
I'm hoping for good weather, so I'm going to say sunscreen.
I would say seasickness tablets.
Yeah, we're already looking into that.
Nice.
Thank you all for coming on this panel. Please give our guests a big round of applause. Thank you. Thank you for coming out. Thank you for coming out. Dan moeten wij weer gaan wisselen. We're doing a small change of things now, small change of scenery. So, in a few moments, we will go on to Carolina, our chief hull and body, who will tell you something about the production and assembly process of our boat. But before we actually can really talk about the boat and how it's been produced, I think now is the time to actually start the boat reveal. So, without further ado, I think we've worked as a team really hard. We put in a lot of hours into this project, and we are extremely proud of the boat we have built, and we are really, really proud to show it to you today. So, on behalf of the team as well, I would like to present to you the boat of the TU Delft Hydromotion team of 2024.
Ladies and gentlemen, good afternoon, and thank you so much for joining us here in Amsterdam. It is absolutely lovely to have each and every one of you here today. So, we have a boat. There it is. Lovely, isn't it? If you're wondering how we got here, don't you worry, so are we. For you, it is an explanation. For us, possibly more of a reminder. The video that I'm about to show you will give you a glimpse into the production and assembly phases of our hydrogen-powered flying boat. Don't worry, I'll be back after.
After months of hard work, we have finally built a foiling hydrogen-powered boat, designed to be the most reliable and seaworthy to date.
The team had to perform as one, to combine our knowledge into one working boat.
We have made each component by hand and put together all subsystems carefully.
The main part you see is the hull, which was entirely produced by our own team members. We spent 10 weeks of cutting fibers, laying carbon and vacuum infusing.
To create a monohull design that's optimized for efficiency and stability on the North Sea.
The sharp bow and larger chine held the boat to effectively cut through the waves and help with liftoff before foiling.
The larger overall hull shape allows for a much wider foil configuration, keeping us stable during flight.
The downside is that the larger hull also means more weight. The foils need to be able to lift 1.8 tons out of the water while keeping drag to a minimum. This is achieved by producing the foils in an elliptical shape.
To foil, we also considered the length of our strut, which is increased significantly to fly high above the waves of the North Sea.
To handle these rougher conditions, we also optimized our height control system, making it quicker and more powerful than ever.
Other electrical systems in the boat were adjusted as well, to maintain reliability and seaworthiness.
And each system is treated in such a way that it can handle the salt water conditions.
Furthermore, we've produced a buffer for quick and easy repairs, boosting reliability.
Plus, we've ensured its durability by testing it for vibration resistance.
Bringing all these components together allows us to safely and comfortably make our journey to the United Kingdom.
Showcasing the real-world application of our boat.
To do this, we also had to look closely at the pilot compartment.
We've implemented an electromechanical steering system to allow the pilots to easily maneuver the boat without having to use great force. Communication became an important factor as well. Losing connection on the sea could cause a great deal of trouble.
We've therefore installed our own internet connection, upgraded our radio systems and installed a reliable navigation system, ensuring good communication and navigation throughout the entire journey.
Now we have started the testing phase and we will fine-tune our systems and prepare for the crossing ahead,
where we will show the capabilities of our boat and the strength of hydrogen.
And become the first ever fully hydrogen-powered boat to cross the North Sea.
Together we can write history and steer the future. Welcome aboard the next wave.
Well, thank you. The next wave is now. It is here, and it stands not only as proof of our commitment to being a force of change in the maritime industry, but also, and perhaps a little bit more tangibly, as a product of the hard work we've been putting in since the last time you saw us at our design presentation. Back then, we showed you the blueprints. Now, there she is. 5 months, 23 students, 1 boat. Our 3 engineering departments, vehicle dynamics, embedded systems, hull and body, none experienced production the same as another, but all our parts and systems came together at the end, and sometimes even during. Vehicle dynamics, our cooling system, driveline and steering, struts and foils, all engineered to the smallest detail. For the first time ever in hydromotion history, we have an electromechanical steering system, sorry about that, as opposed to a strictly mechanical cable-based steering. And this is because Mick, our steering and driveline engineer, would not have it any other way. And rightfully so. I mean, over 10 hours in the North Sea with manual steering is not ideal at all. And another notable element of this year's innovations in steering is the implementation of a rudder system, which you can see very visibly integrated into our rear strut on account of being orange. Over the past years, we had been steering by rotating the entire rear strut, which was not as convenient. And besides its convenience, the rudder system has the distinguished advantage of leading to more uniform, more predictable, induced loading on the structural elements at the back of our boat during steering, maneuvering, sailing. So you can see that vehicle dynamics is more than just our wing guys, or you can say our wingmen and doors, of course. They also make the massive pieces of aluminum attached to the wings. And speaking of aluminum, these guys do 99% of all the metal working for the team. I'm talking milling, lathing, CNCing, you name it. Jan, our foil engineer, not only completely designed our foils and coordinated their production process, but also spent countless hours in front of the CNC machine meeting everyone's part requests. But he did make sure that we knew it. If you look into the back compartment of our boat, you can see the steering arm, and you can see engraved into it the word Jan. Mick, the guy who actually made the part, did not find that as funny as you guys did. but it's all right. Speaking of foils, I mean, foil production was, of course, central to vehicle dynamics. They left the comfort of the Dream Hall, our workspace, to go make their foils at Q Concepts in Doetinchem. And for 4 weeks, they stayed at the Luxe Chalet, which is a form of accommodation best described as a trailer with a flat screen. And they rose early every day to face a day packed with either carbon fiber laying, cutting, curing, sanding, or some combination of these. See, our foils are made of 100 layers of pre-impregnated carbon fiber. Somewhere in the middle, there's an aluminum insert that makes sure that after the foil comes out of the oven, so after it's cured, there will be a flat part at the top, which then ensures it can be attached to the strut as you see it over there. In practicality, what this means is that it takes one person 3 days to lay the fibers to make one foil. So it's hard work, and it took them a while, but they came home with 6 carbon fiber foils that will help us carry 1.8 tons of boat above the waves of the North Sea. Embedded systems through cables, connectors, a battery, printed circuit boards, and much more. They manipulate electricity through our boat at their will, and in doing so, create a fully functioning electric boat, a series of interconnected and communicating systems and subsystems. These guys experienced production a little bit differently from the other 2 engineering departments. They would design something, implement it, find its faults, back to the drawing board it went, over and over, since design onto production to this day. And when you have 1 year to create a bunch of systems, implement them, iterate on them, it's easy that when something breaks, that you fix the problem instead of finding the underlying cause of that problem and fixing that. But this year, this department directed great focus towards the reliability and durability of our systems. We are going to be in the North Sea for a while. It's nice that things don't break in the middle of the sea. They took no shortcuts. For example, they completely redesigned our power distribution system and implemented safer ways to fail. Safer ways to fail. What does this mean? I asked Dan, you've met Dan, and he said, implementing safer ways to fail in this context means that when there's a fault, it is detected by a circuit breaker. And for the Dutch crowd, that's a stop from your stopcast. So they're detected by a circuit breaker as opposed to the refreshing smell of fried electronics and the joy of having to remake a circuit board over and over again. They've also built up on our dashboard. We now are able to see graphed data on multiple parameters of our boat with under-second delays, which has already been useful during testing and will continue to be useful and be useful during our crossing. And on top of that, they have demonstrated substantial delegation skills. They recruited half of the team to spend 3 hours soldering their electrical components onto green circuit boards. And they even gave us some certificates to immortalize our experience and our expertise. And they're signed by Dan. If he does decide to pursue a career as a host, they might even be worth some money someday. Who knows? And finally, they have achieved decent cable organization, which might not seem like a feat, but trust me, for an embedded systems engineer, or any electrical engineer really, it is truly the biggest feat of them all. These guys, they have been building and they continue to build the beating heart of our boat. Hull and body. Hull and body. It's in the name. We made the hull and entire internal structure of our boat over the course of 10 weeks at Contest Yachts in Medemblik. During that time, we lived in a nice little house by the IJsselmeer, hosted by a German lady, Michaela, who coincidentally owns a concerning amount of sea-themed decoration. There must have been at least 20 sea turtles in that house. No week over there was the same, and every week someone from the team, from another department, would put their work on hold and come join us for a nice week of good old manual labor. It was intense, but it was truly remarkable. We got settled at the composites hall over there, which quickly became home to countless rolls of carbon fiber, tools, materials. And over the first weeks, we focused on the infusion of 13 carbon fiber plates, which will then be cut to become our bulkheads, our stiffeners, our deck. We gathered experience from many of the composite technicians. We learned all the ins and outs of composite manufacturing, everyone's own little tips and tricks to a high quality final product. You know, all the things that you don't learn while studying for your aerospace structures and materials exam. And then our mold arrived, and it was massive. Turns out that an 8-meter long boat is much smaller on your computer screen than when you're applying 6 layers of wax to its mold using a sponge the size of your hand. Understandable. But we prepped the surface, we laid the fibers, and our hull was infused successfully. It was quite lovely. We then shifted our attention to the internal structure, and as we installed upwards of 60 bulkheads and stiffeners, I couldn't help but think back to all those times when Liam, our internal design engineer, would come to me and say, "Look, Caroline, I've made another stiffener." And I'd be like, "Looks good, man," because we spent days installing them. But you can be sure that this is one stiff boat. We then demolded, and as the black shining surface of our hull emerged from this mold, we felt, of course, a sense of relief. It was a beautiful moment. It was the culmination of weeks of work, and soon enough, it was making its way back to Delft. Now let me pause and allow me to mention the guys that over the past months have been working more silently than us engineers, and that's our operations and management. Operations has spent the past months taking thousands of pictures for our dear partners, some of whom are here. Thank you to those who are. And showing the world what us engineers are up to through social media, newsletter, etc. Sometimes don't even know we know what we're up to, and operations has to imagine that. Organized countless events, including this boat reveal at this very nice location with this very nice decor. And if you look at the wrap on our boat, you can probably deduce that it hasn't been designed by an engineer. And then we have our management who has been facilitating everything that we've been doing since the beginning. We have our team manager who has been making sure that we're happy and hydrated and a cohesive, high-performing team. Our project manager who has zero tolerance for mismanaged time and keeps all the trains running on schedule. We have our chief engineer with unyielding focus on ensuring the quality of all the technical aspects of this project. And finally, our operations manager, who you've met, who manages operations and also keeps us far away from bankruptcy, which is very important. Things cost money. This boat wouldn't be here without money. Things are expensive. These guys, management, they have been the silent force steering our project in the right direction since design, onto production, onto assembly, and until now. Now back to the engineering. The hull's arrival in Delft marked the beginning of a new stage for our project, a new phase that was assembly. During assembly, everything went into the boats. We had countless holes drilled, tools scattered, glue cartridges emptied. We took up so much space. You know, we dimensioned this boat with the dimension of the door of our workshop in mind. So had it been bigger, it would not fit. That's why it's not bigger than this. However, we have not once actually kept it inside our workshop. It has been taking space that belongs to the other teams as well, and they've been quite lovely with us about that. But that was assembly. All the newly created compartments were filled. All of embedded, neatly organized cables went in. Hydrogen systems assembled, went in there. Cooling, steering, everything you can imagine. Our deck was glued on, our hatches were installed, the boat was wrapped, everything came together. And even though over the past months we have been playing such different roles in this process of creating a boat, we constantly saw our parts and our systems and our people come together and intertwine, and it is only with this attention that we have given the interfaces spanning this entire team and this entire project. It's only because of those that we're able to stand here today and show you this boat. So together, I invite you to believe in us. I invite you to join us, because in 2 months, we will be soaring over the waves of the North Sea. Ladies and gentlemen, thank you very much.
Well, thanks, Carolina. Nice that you're still here, because I wanted to ask a question, which you, of course, did not know beforehand. What was your favorite moment during production?
You know, we have rehearsed this question, and every time I have given Dan a different answer. And the truth is, up until now, I didn't know what I was actually going to answer. I could give 1,000 different answers to this question. Truth is, there's not one favorite moment of production. Production was a series of small, notable events that culminated to what for us was a hull, what for vehicle dynamics might have been foils and struts. So, to name a few, demolding was lovely. It was a massive sense of relief. It was a beautiful moment, and the black, shiny carbon fiber hull was absolutely amazing. But also the feeling of infusing a plate when you've spent an entire day doing the setup and it goes well. I used to talk to one of the guys over at Contest Yachts about his piranhas. I found that very interesting as well. And sometimes even
You're now combining all the previous answers.
That is true, but that's just to name a few, and production was lovely. Thank you for the question, Dan.
No problem. Thanks again, Carolina. So before we end today, and we will have drinks here behind the boat, and you can go all admire the boat up close. We want to take a look back at today and a look into the future, into the next couple months of what we will be doing. So today we have started off by a lecture talk from Ad van Wijk about hydrogen. He told us about the mysterious gas, how we can use it, and why we need to use it. Then we moved on to a panel discussion about sea travel, and we've heard from John Gill and Marco Rebijn about how we can conquer the seas and how we should prepare us for that. And we've, of course, also heard from Alice about how we are actually preparing ourselves for that travel. And then finally, we've heard from Carolina just now how the production and assembly phase was. Which brings us on to the next phase. And the next phase will be testing. So over the next 3 months, 2 months, a little over 2 months, we will be going from putting our boat for the first time in the water to actually having a hydrogen-powered foiling boat to cross to England. And with that goal in mind, we will be working not only as a team, but really as a group of friends on making this possible, on making the first hydrogen-powered foiling boat that will cross to England. We will show that change is possible, and we will demonstrate our vision for a sustainable maritime industry. And we are so glad that you are all here to join us. So, on behalf of the whole team, I would like to thank you and to welcome you aboard the next wave. So, before we actually go, and now it really is the last time, we of course have to christen, or as we say in Dutch, doop the boat. So for that, I would like to ask Ad van Wijk, and of course our whole team, to come up to the boat to dope it.
I wish you, I christen you hereby, and I wish the crew, the whole team, the Hydromotion team, and all of you a safe and very inspiring trip.
All right. As a final announcement, I said before that this was gonna be the final thing, but behind the boat we have a bar. We would like to invite you to come drink something with us and look at the boat, look at all the things we've brought from our history, from systems that are going into the boat, and have a talk with us. So thank you all for coming, and hopefully we'll see you at the next event. Can I announce this? The Bon Voyage, when we will actually set sail. Thank you.